Welcome. This is Unit 5, Day 5. We are on page 21 of the note packets. We're going to be doing a lot of solving in the next few days. Some of it's going to have exact answers, some of it's going to have decimal answers, some have calculators, some have non-calculators. So a lot of times you're going to see logarithms, and we're just going to have to figure out how to deal with it. Sometimes you're going to see natural log and e. Alright, so number one up here, you start seeing log of something of 2 equals 3. I'm trying to figure out what base. So if you can't think of anything to do, try to rearrange the problem into an exponential. So we'd have x to the third equals 2. Alright, well, we can get rid of the power of 3 by doing a cubed root. So whatever we do to the left, we do to the right. Those cancel out. So I don't know, that's a decimal, I don't know exactly what that is, so I'm going to leave it as the cubed root of 2, or you can write it as 2 to the 1/3 power. And that's it. So I'm like on letter B. So we have log base 1/3 of x equals -3. I can't do anything like this, so I'm going to rearrange it a little bit. My base of 1/3, -3 is equal to x. There's my exponential. I can deal with this now. I can flip it with a -1. 3rd power makes 27. Letter C. Well, we've done change of base and we know how to use that on the calculator, but if we're doing non-calculator, let's try to rearrange it again. So 4 to what power is equal to 64. So if it's the base number you need and you just need an exponent, just start raising it to the first. So 4 to the 1, 4. 4 squared, 16. 4 to the third, 64. Alright, so I know my answer is 3. So 4 3 times is 64. Again, rearrange. 9 to the 3/2 is equal to x. With the 1/2 power here, I square root it, so I have 3 to the third. I get 27. Alright, something like this, I rearrange. 3 to the 0, 2x minus 5, and now it's just algebraic 1. Now, here's letter F where we start getting into stuff where we start bringing them into one problem. So we're going to condense first. Alright, so I bring it into one log. So log base 6. And when I have addition, I change it into multiplying. So I multiply 2 times 18. So those two together. Alright, so log base 6 with 36 equals something. You might know what it is. It's basically 6 to what power is 36, or rearrange it. Same thing on letter G. Instead of subtraction, we actually divide the two. So I have log base 5, and it's 75 over 3. So log base 5 of 25 equals something. So 5 to what power is 25, or it's just 2. You can rearrange if you want. It's 5 to the second. Oops, 5 to the x, sorry, equals 25, and that's how I get the 2. Now remember, when you get to letter H, ln and e cancel each other out. Okay, so ln and e cancel. You're left with a 2. ln and e cancel each other out. It's minus 5, so you get -3. Letter I equals to something. So if the rearrange 3 to some power is -9. If I did 3 to the second, I would get a +9. So that doesn't work. If I get 3 to the negative 2, that's 1 over 9. So this is kind of one to pay attention to. I can't have a number to an exponent and ever get a negative, so this is no solution. Alright, solving exponential. We have done some of these. 2 to what power is 8? Alright, so if you can do it right away, so 2 times 2 times 2, so x is 3. Some of them not so bad. If you can do it right away, say and get that, that's fine. Now letter B, we've done stuff like this where I need the same base. So I'm going to do a factor tree, so it's 3 times 3. So it's 9 is 3 squared. The x is with that one, so I'm going to leave it there. 27 is 3 times 9, 3 times 3, so I get 3 to the third. When the bases are the same, they kind of cancel each other out until you set your exponents equal. So 2x is equal to 3, x is equal to 3 halves. Same thing on letter C. I have my base of 2. Well, let's break 16 down so it can be in terms of a 2. Okay, it doesn't matter if you do 4 times 4 or 2 times 8. So 2, and I have 3x plus 1 on the left. 16 is 2 to the fourth. Since the bases are the same, the exponents have to be equal to each other. So I set 3x plus 1 is equal to 4. I have 3x is equal to 3, and x is equal to 1 then. Alright, on these we're definitely going to work with the calculator a little bit. So anytime you see e to the x, ln is not there yet. So e to the x is equal to 5. That's our starting point. I want to get rid of e, so if you have e there, I'm going to apply an ln to it. So whatever you do to the left, you do to the right. So x is equal to ln of 5, and on my calculator, if I do ln of 5, I do get 1.609. Now letter B, it's already in that exponential form which we rearranged it, but this is, I can't do anything like this. I can't divide by 10 because these are not multiplying. This is an exponent. So there are times when instead of the exponent, you want to rearrange it back into the log problem. So log base 10, and no, you don't have to write the 10 there because it's implied in the calculator, of 200 equals x. And this is the calculator part. So the calculator already works in log base 10, so it's just log of 200 and 2.301. Now, these are just a little bit of variation on that. So e to the x, same kind of thing as above, but first I need to move the 5 over. Okay, e to the x is 55. Now it looks like above, so to get rid of the e, I ln to both sides. Type in ln of 55, and I get 4.007. Next one, a little bit like above, but I have a little bit more going on in the problem. So I cannot multiply the 4 and the 12. Do not do that and make it 48 because order of operations says you do exponents first and then you multiply. So I'm going to get rid of the 4 because it's just sitting there and it's kind of clogging up the problem. Equal 1.25. Alright, so now this part looks like what I started with here. If I can't do anything with it, I can't square root it, I can't do anything. So if I can't do something like this, I'm going to change it into a log and see if I can work with it that way. Log 12, 1.25 is equal to 2x. Okay, and then I can just divide by 2 when I'm done. Okay, so some of your answers are actually going to ask you for exact answers. So this is exact. It looks messy and gross, but it's exact. On your calculator for decimal, log base A, and I type it in 12 and what, 1.25, and divide by 2, round at the end, 0.045. So the exact answer would be this, so no calculator involved. The rounded answer would be that. Okay, so up above, this is exact. This is the rounded. All right, next one. When you have two of them that are not the same, you don't know where to start. I can't break a 7 down into a 1 and a 7. That doesn't help. Change it into a log. So log base 3, 7 to the 2x. So that switches with that. All right, doing some of our properties. This one moves to the front. 2x times log 3, 7. Now I could actually figure out what decimal this is on the calculator. So I'm gonna go up and figure out what that is. Log base 3. And so I get 2x, 1.77. And now I just kind of do the problem a little bit more algebraically. 2 times that is 3.54. Subtract x is 2.54. Oops, x, sorry. And then divide -2 divided by 2.54. -0.787. All right, this last one involves some factoring, which we'll do later, so we'll factor tomorrow. If you want to try it, go for it. Otherwise, I'll see you tomorrow. Thanks. Bye.